Hi, I'm Aanas, and today we're unboxing the Nexperia motor driver evaluation kit. It's designed to be very versatile and customizable so that you're free to prototype and experiment as much as you'd like. We've got the QR code here, which will take you to all the materials that you'd need. So let's unbox it. So we've got the leaflet with the terms and conditions, but it's also got this really useful graph that shows you the wiring for the setup, so you always don't have to refer back to the user manual. So you've got the controller board, inverter board, and let's plug in our microcontroller. And with the motor, it comes pre-wired with the Hall effect sensor, so you only need to wire up the inverter board and the Hall effects go there. There you go. To power up the board, you've got a couple of different options now. So you could power it up using the USB-C connector here, which you can drive with any laptop charger that you have, and it's able to do up to 100 watts. Alternatively, you could use these connectors here or the banana connectors as well, so you can power this board up to 1 kilowatt using that. So we're going to be using the USB-C connector here, and when you plug things in, you can see that there's a startup sequence, but also everything is green, so that just means everything's all working now. To turn it on, you just flick on the enable switch, that starts spinning the motor. Alternatively, you can also change the direction as it's spinning. Hopefully you can see that. Also you can change the speed. Now let's talk a bit about the setup here. So regarding connecting the motors, you've got quite a few options here. We've used the terminal blocks here because that's really easy when you're trying to work with smaller motors with thinner cables. But let's say you've got a bigger motor with bigger cables, you can simply use the screw terminals right here on the bottom. They already come with the screws, so you just need to plug it in. You might also have a custom connector that you're using that your motor cables need, so in which case you can just use these connectors there, just solder them on. We've got a couple of different current sensing methods as well. So we've got on this side a high side current sense, and that's for the VV bus, but then you've also got on each individual phase, we've got inline current sensors, and that you can use for more complicated driving methods such as FOC. We've got here, as you can see, the MOSFET, and then regarding all the test points, you can see that we've sort of spread them around. We've kept a bit of space here so that you can easily desolder components, but also access all of the test points very easily on the board. They're also very well documented on the board itself. So on each test point, it tells you what the signal is, and you don't always have to refer back to the user manual. We're trying to keep it as easy to set up as possible. Moving to the controller board, we've got our Nexperia gate drivers here, but also on the left of this, we've got our zero voltage crossing back EMF detection circuitry. So you can easily program in to do a sensorless drive as well. Here we're obviously using the sensor drive, using the Hall effect sensors, but you can also use other type of sensors like encoders, etc. on this. On here we've got the controls, which we've demonstrated already, including the potentiometer, but we've also got a bunch of fault LEDs. And we've put as many of those in possible because it's really easy to debug then. We've also got user definable LEDs, which you can program into any of your own individual error codes. We've also got a different way of powering this board if needed. So currently The inverter board, we have one power supply connected, but then that powers all of the individual boards. So that's got a DC-DC converter on there that steps down the voltage to 12 volts, and that powers the gate drivers. Now you might want to drive the gate drivers at a different voltage, and you can do so by just powering this board separately using anywhere between 9 to 16 volts using this connector here. We're here using a Leonardo board, but also there's other options here as well. You can use any nuclear board as well, so it supports both this nuclear board form factor and the Leonardo form factor. If you'd like to get your hands on one of these kits, head over to nexperia.com for ordering options. The evaluation kit is also open source. That means you've got access to all the design files, all the user manuals, schematics, and simulation circuits, all on nexperia.com and also on GitHub. Thank you for watching.